Salutations, mini mathematicians. Sorry, my document camera is taking a minute to focus. Apologies. So we're going to be looking at 6.1c homework. 13 through 16, you need a protractor complete. So 13 says a triangle with sides that measure 3, 4, and 5 centimeters. Does this form one unique triangle? Remember, we did our station activities, so we know when we can have one or more triangles with a given description. So first of all, I probably want to check the triangle inequality theorem for this. So remember, A plus B has to be greater than C, where C is the largest. So 3 plus 4 is greater than 5, and 7 is greater than 5. So we know this will make a triangle because they will try and trick you sometimes, and you're not getting tricked today. If possible, what kind of triangles form? If not possible, state why not. So taking a look here, if we have 3 sides, we will have one possible. There's only one way to make this triangle. There's just one. So if possible, what kind of triangle is formed? If not possible, state why not. So this is, yes, one unique triangle. And this is going to be a scalene, and we will take a look at what the angles look like. So this is probably one of the more difficult ones to draw on your own because we're not sure what the angles are. So first of all, we'll start with the longest side. Let's start with the longest side of 5 centimeters. So here to here is 5 centimeters. And then we're going to have 4 centimeters, which is this long. And we're going to have 3 centimeters. And notice the 3, does it match? It matches, okay. Here. So I got kind of lucky that they matched up. And it looks like this is a right triangle. Sometimes after you draw the first part of 5 centimeters, if then I had put the 4 centimeters up too high, it wouldn't meet. Or if I put it too low, it might be too close. So I usually like to draw in the 4. And then looking at the 3, oh, that kind of fits. I would need it a little bit bigger. So just make sure you're using a pencil for this when you're drawing it, so you could always make it a little bit wider or narrower as need be. And if we measured this, we might need to extend this line out so we can measure that angle. You notice it's going to, 90 degrees. It's not going to be a 45, 45, 90 triangle, I know, though, because the side lengths are different. So let's measure the other angles. I'm going to have to extend out my side length so I can get an accurate angle measure. Let's see. I'll extend out this one as well. Looks like it's between 50 and 60, so it's 55 degrees. And excuse the bell. If we extend out this one, looks like, well, we hope it's 90 and 55 get you 145. So we're looking to get to 180. So like I was just saying, let's see if you can see this. We have 55 and we have 90, which got me to 145. If I subtract 180, we should have 35 degrees. I'm just ignoring the negative because I can do that. So I should have about 35 degrees. And if we look, it's pretty close to 35. I probably could have done a little bit better job. Well, see there, 35 degrees. So this is a scalene right triangle. Okay, let's take a look at the next one. So the next one gives you a triangle with angles 100 degrees and 20 degrees and an included side of 2 centimeters. So we talked about how when you have an included side, it limits your options for where that next side and angle have to go. So because you have an included side, and I'm telling you this has to be 100 degrees and this has to be 20 degrees, where these two angles will meet at, there's only one point. So this is going to be one unique triangle. And I know it's going to make one unique triangle because of that included side, and 100 degrees and 20 degrees, we can still make a triangle because we have less than 180. So we know this is one unique triangle. So let's start with the 2 centimeters. I'm going to start with making a longer line first and then measuring out 2 centimeters on it. So here's my 0 and here's my 2. Again, I'm using, oh my gosh, on the last one we forgot to label it like triangle ABC. So this is triangle ABC. Oh my goodness. Can't believe that. Okay. So let's label this one AB, and that's 2 centimeters. And we are going to label 100 degrees and 20 degrees. I'm just use A for the 100 degrees. So from 0, I'm going on the inside all the way to 100. So make a dot above and below. Oops, couldn't see that. Make a dot above and below the 100 on the inside numbers. And it should be, slightly more than 90 degrees. And then angle B, I'm going to extend this line out a little bit more just so I can be really accurate. So angle B on the 0. Okay. Sometimes you really need to be right on top of your protractor to see if you're lined up on the angle nicely. And we know this is going to be 20 degrees, so I'm using my outside numbers here to 20. Really important to put that dot on the above and below mark. And lining up all 3 dots as well as you can. So this is 100 degrees. Almost looks like 1,000. 100 degrees. And this is 20 degrees. So if we have 100 degrees and 20 degrees, we're expecting this to be 60 degrees. So if I measured it, give myself a vertex here, label it C. Measure AB, so I'm going to extend out AB. And take a look. Boom, 60 degrees. I'm just going to draw a little arrow, 60 degrees. Wonderful. So here's our labeled picture. Since it's labeled, we might as well label all the sides. So this one ends up being maybe about 2.5 centimeters. And this one ends up being about 1 centimeter. Perfect. So if possible, what kind of triangle is formed? If not possible, state why not. So this is a obtuse. scalene triangle. Nice work. Okay, let's move on to the next one, 15. So 15 says a triangle with two sides of 5 centimeters, missed out the centimeters, and 7 centimeters, and an included angle of 45 degrees. So very similar to last one, because there's an included angle, it's not going to give us any options for the remaining sides. It's going to predetermine where our triangle is, so it is going to form one unique triangle. If I made a quick sketch, because that's an included angle, this has to be 45 degrees. This has to be 5 or 7 centimeters. This has to be 5 or 7 centimeters. So that last side that we're connecting, there's no other options except where it is. So this is going to be one unique triangle. That third side and the other two angles are predetermined because we have an included angle here. Okay, so let's start drawing this. I'm going to start with the 7 centimeters. So you probably know by now I like drawing a nice long line and then measuring 7 centimeters on it. So we'll start with the 0 and then go to 7. We'll have A and B, and that this is 7 centimeters. An included angle of 45 degrees. So we can make A or B 45 degrees. It does not matter. It's still a unique triangle because they're just mirrors of each other. I can still cut them out and rotate them to be the same. So let's measure this 45 degree angle using the inside number at 0 all the way up to 45, which is in between 40 and 50. Make the dots on either side. Extend that out. Label our angle as 45 degrees, and then go ahead and measure off 5 centimeters because it is an included angle. Included means in the middle. So here's C. And if I connect C and B, I think, ooh, that sure looks like a 90-degree angle to me. So if we measure it, right there, boom, at 90. So I'm going to just put my little square there. That means 90 degrees. And then measure angle B, which should be right at 45. And I could extend out this line just to see it better. So if I extend out that line, it's right there on 45 degrees. So I know this must be an isosceles right triangle. So if I measure these two side lengths, AC and CB, they should be congruent. So just around 5 and, oh, line it up at 0, just around 5. So 5 centimeters, 5 centimeters. This is an isosceles. Isosceles. Isosceles because there's two sides that are the same and it's a 90 degrees, so it's an isosceles right or right isosceles, however you like to call it. Isosceles right. Okay, last one. We have a triangle HIJ. Oh, the other ones were not labeled. Okay. A triangle HIJ in which measure HIJ is 60 degrees, measure JHI is 90 degrees, and IJH is 55 degrees. Does this form one unique triangle? Well, before you start drawing it and thinking, oh, if you are just given angles, I can make those side lengths many different things and I have more than one unique triangle. Well, hold your horses. They might be trying to trick you because if you have these angles of 60 degrees plus 90 degrees, plus maybe that big hint was there's only one that ends in a 5. Oh my goodness, 205 degrees? That is not going to make one unique triangle. Does this form one unique triangle? No, it does not. Why not? These angles add to be 205 degrees. Should we say always triangles add to 180? Interior sum of all triangles are 180. These angles add to be 205 degrees. All triangles have 180 degrees. Hence, this cannot make a triangle. Not applicable for the picture. Excellent. Great work, mini mathematicians. Good luck with your triangles. Do your best. Be nice to everybody.